Hello, PreCalc. Here we are with 3.2 log functions and their graphs. We previously covered the graphs when we did our graphing unit, and now we're looking at the algebra part. For every function of the form f of x equals a to the x passes the horizontal line test, and therefore it will have an inverse. And this inverse to the exponential is called the log function, or log base a. For x is greater than a, or x is greater than 0, and a is greater than 0, not equal to 1, you have y equals log base a of x if and only if x equals a to the y. So if I'm reading my log one over here, the answer to a log is an exponent. Alright, it's doing the opposite of the exponential. So y is the power on a that gives me x. A to the power of y gives me x. So that's how I kind of read it backwards and forwards. The equations y equal log base a of x and x equals a to the power of y are equivalent. The first is in log form, and the second is in exponential form. Okay, the logarithmic equation 2 equals log base 3 of 9. 2 is the power of 3 that gives you 9, can be rewritten as 3 squared equals 9, or 9 equals 3 squared. The exponential equation, 5 to the third power equals 125, can be rewritten in log form. Remember, log is going to give you the exponent for the answer. Log base 5 of 125 equals 3. 3 is the exponent on 5 that would give me 125. And that's how I kind of think about the log ones. I turn this around and kind of think of it as an exponent. What exponent would give me this? Okay. So we're looking for log base 2 of 32. So what power of 2 would give me 32? So you can either think about it, you can do, that's basically it. So for these nice ones, you just need to think about it. What's the power of 2 that's going to give me 32? 2, 4, 8, 16, 32. It's the fifth power of 2. Okay. F of x equals log base 3 of x. What if x is 1? So log base 3 of 1. 3. So what power of 3 gives me 1? Well, 3 to the first is 3, so how do I get to 1? Okay, it's a tricky one. 3 to any power, or anything, any base to the power of 0 will give you 1. Right? 3 to the 0 power is going to be 1. Log base 4 of 2. So what is the power of 2 that gets me, or what is the power of 4 that gets me to 2? 4 to what power equals 2? Well, the square root of 4 would get me down to 2. How do you write the square root in a fraction, or in an exponent fraction? Okay, the square root would be the half power. The half power. What is the power of 10? That would give me 1 over 100. Okay, let's think about this the other way. What power of 10 would get me to 100? 2. 10 squared is 100. Now, how do I flip that upside down to 1 over 100? What's a negative? Okay? negative exponent would flip it upside down. So 10 squared would be 100. 10 to the negative second, 1 over 100. The log function of base 10 is called the common log. It's denoted by log 10 or simply log. It's the log you see on your calculator. The log on your calculator is going to be log base 10. The following properties follow directly from the definition of log function with base a. Okay, so if we have log base a of 1 equals 0, that's because a to the 0 is going to equal 1. Any base to the 0 power comes out as 1. Log base a of a equals 1. 1 is the power of a that gets you back to a. Log base a of a to the x equals x, and a to the power of log base a of x also equals x. Okay, because logs and exponentials are inverses. When you're doing a log of an exponential or an exponential of a log, they're going to cancel out, and then you're just going to have the other numbers that fall down. And if log base a of x equals log base a of y, then we know x equals y. That's our one-to-one property. If the bases are the same, then we can compare the other parts. Let's do some math. Simplify. Log base 5 of 1. So what is the power of 5 that gives me 1? Or think about it like this. 5 to the what power equals 1? It's 0. Log base radical 11 of radical 11. Okay? Log base a of a. What power of radical 11 gets me to radical 11? 1. And then exponentials of logs of exponentials, 8 to the power of log base 8 of 30. Okay? These would cancel out, and you're just going to be left with the 30. Whenever you do an exponential of a log of that same base, or a log base of an exponential with that same base, they're going to cancel out. A little bit more common sense here. Log base 5 of something equals log base 5 of something else. The two somethings have to be equal. The only way those would be equal is if y was 16. Okay, log with no base, that's going to be our common log, or log base 10. Log of this equals log of that. Those two things need to be equal then. So set them equal and solve. I'm going to add my 3x over, so I'll have 4x minus 2. And we should get a half. Okay, and then C, same thing. Log base 3 of something equals log base 3 of something else. Okay, subtract over. And square root. We'll get plus minus 5. We need to watch out. I believe we need to be positive in here. But because we're squaring it, it's going to come out positive, and we'll be okay. Natural log. Okay, e to the x is also 1 to 1, so it'll have an inverse. And the inverse of e is going to be the natural log, or ln of x. It's the log base e, so it's going to have its own special one. So log base e of x is going to be natural log of x, and then again, that part needs to be greater than 0. That's called our natural log. Alright, same rules there. Y equals natural log of x, and x equals e to the power of y are equivalent. The same little rules we have for flip-flopping from exponential to logs. Use a calculator. So we'll just do a couple of these real quick. just to make sure we know where it's at. Natural log has its own button. Partner with the E button conveniently. So natural log of 2, close it. We have 0.693. Okay, let's do this one over here. Natural log of -1. Error. Non-real answers, okay? Because we need our x's to be greater than 0. So this is undefined. Alright, some more properties. Natural log of 1 equals 0 because e to the 0 would give us 1. Natural log of e equals 1 because e to the first equals e. Remember, natural log is log base e. So if you're doing log base e of e, of course it's going to be 1. 1 is the power of e that gives you e. Okay, natural log of e to the x is going to cancel out to just x, and e to the natural log of x is going to cancel out to just x, because you're doing log and an exponential of the opposites. Remember, natural log is log base e. And just like with the other logs, natural log of x equals natural log of y, then we can compare x and y. Simplify. So natural log of e to the 1/3. Remember, natural log is log base e. So log base e of e is going to cancel out, and we're just going to have the third. Again, e to the natural log of 8. Those are opposites there. Their inverses are going to cancel out. We get 8. 15 times natural log of 1. Okay, what power of e gets us to 1? E to the 0. So this is 0. Remember, we're doing log base e of 1. What power of e would give me 1? 0. So that's why this is 0. And 15 times 0 is 0. Natural log and e are inverses. They're going to cancel out, and they're going to be 1 over 6. Okay, domain questions. Just like with our other logs, the inside part needs to be greater than 0. Alright, just keep that inside part greater than 0. And let's do a story problem. Students participating in a psychology experiment attended several lectures on a subject and were given an exam. Every month for a year after the exam, students were retested to see how much of the material they remembered. The average scores for the group are given by the human memory model. Okay. F of t equals 75 minus 6 times the natural log of t plus 0, where t is time in months, 0 to 12 months. So what was the average score on the original? Okay, let's find out there. So we would have 75 minus 6 times natural log of 0 plus 1. Natural log of 1 okay, well, what power of e would give me 1? 0. E to the 0 is 1. So we have 75 minus 6 times 0. 6 times 0 is 0. So the average score was 75. Okay, let's figure out what we got after 2 months. I guess I can put it over here. 6 times natural log 2 plus 1. 75 minus 6 times the natural log of 3. And this we're just going to type in. And we have about 68.41. Okay, let's have you practice there on the last one, 6 months. And for 6 months, you should get 63.32. All right, there we go, folks. You should have plenty of time for homework. Get some math problems done. We'll see you next time.